Yes.
Check, check, check.
Excellent. Well, good afternoon, people, and huge apologies about the teeny-weeny room. I don't know why, but so hopefully, so we're nice and packed out, so hopefully we are worth coming along to, because there's lots of other very good ones. And actually, for this session, I must say, I'm actually quite nervous for this one. I didn't actually realise we've actually got some quite famous people in the audience today. So I don't know if you guys know, but down here we have young Tim, who was in The Hobbit. Dude! Hobbit.
And the star of Goodbye Pork Pie.
Yes. Brody. Genuinely was in Goodbye Pork Pie, yes?
Andy was on Celebrity Squares.
I was on Celebrity Squares. Thank you.
So,
no, I didn't win.
Else famous in the audience?
Any other famous people?
No.
No, it's all just down here. No, so there we good. So anyway, good afternoon. Look, we're going to do Architecture 401 TechEd, Designing for Attack. I have here Kirk Jackson, the Security Architect 4.0. They do some online accounting software.
And this is Andy Prow. He's the Managing Director of a company called Aura InfoSec, and they do InfoSec.
Yes, we do. With a certain aura. No, cool.
Cool.
There we go. Well, that's that. That's the first.
Okay, so what are we going to talk about today? Okay, our title has 2 colons in it, which I hear is grammatically bad. Today, we really wanted to do a talk aimed at architects, so that's what we're going to try and do. So today's talk is really about the points that you can insert security thinking into your life cycle, so earlier on. So I've worked with Andy before. Something we commonly see is that security comes along a little bit too late in the whole process. So that's really what we're going to be talking about today.
Yes, it is. And in particular, one of the bits that we'll be reiterating is engaging the business to get your security right. So when we're talking about security architecture, right, we're not just going to be talking about designing the technical bits correctly, but it absolutely has to be relevant to the business's security needs. So,
I forgot to press the button.
Oh no, you've got to press the button, you press my button too. Awesome. Okay, cool. We've actually both got clickers. So
Clicker wars, you go.
I'll do that one. So I guess so we've only got one clicker today.
My clicker.
So it's also a message, right? So the message is that poorly designed security will be bypassed. Human nature is that your users they're not dumb, they're not lazy. What they will do is they will do dumb and lazy things to try and get through their day in the most efficient way possible. So I refute the fact when people say our users are dumb. Absolutely not. They're actually very smart, which is why they bypass the security that you've got in place so that they can just do stuff more efficiently because you keep putting security stuff in their way. So so if you happen to be like the fellas down here, this is actually quite cool with a full room. So these guys down here are actually lying on the floor with their heads on a bag. That's actually quite a chilled way to watch a presentation, isn't it? So you know, if it wasn't
quite, they're asleep by the end of it.
Yeah, it's good. So the takeaway. So what we want to do is security architecture is not just a technical exercise. You don't do it just during the design phase. The security architecture, if you're going to design a secure app that is going to stay secure over a long period of time, it has to be driven by the business needs, and it has to be driven by operational security.
So what do we mean by that? Stay tuned.
Operational security, eh? So this is an interesting one. We're actually at a scoping session with a large client. I'm not going to say if they were government or private sector, but they were a large client. And so we're sitting across the table and we were just scoping out the security testing for their application. So sitting in this room, we had the security architects, enterprise architects, technical architects, we had the project managers, we had the developers, and they're saying, right, and we're going to scope attacking their big new web application from the inside, from the outside, as an anonymous person, as a logged in user. And then we brought up the subject and we said, well, what about the requirements for you testing the operational security? And they kind of went, you mean operational security? We said, well, operational security. So when this thing goes live, then surely when we do a big rich pen test from end to end, don't you want to know how the application looked when it was under attack? Who's going to look through the logs and audit so you can recognize if it gets attacked again? Or how does it stand up? How quickly do you recover it? So that's what we mean by operational security, not just pre-go live, but when it's alive and living. And so the team was sitting around and they were going, oh, no, we don't do any operational stuff. We're the dev team. And as soon as we finished, we hand it over to Ops, which isn't for the client. That's in fact a completely separate organisation that manages the operations. And that's a clear line and delineation. So the dev team and the architects were only responsible with go live. After that point, see ya. There was no such thing as operational security. And one of the key things that we would say is that operational security is relevant to the day-to-day life of your application, right? So sure, you can do some stride, and we'll run through some stride and some threat modeling, and that's a good process to do, just so you get your design right. But if you're not considering incident response, if you're not thinking about what happens when it goes live, then you're going to be in big trouble. And especially if we look at the big systems that are security breached, it tends not to be the big new shiny ones that have just gone live. It tends to be the ones that have been out for 2 or 3 years. They haven't been patched. Nobody knows who wrote the code anymore. In fact, the guys who did write the code have moved on and no one knows what it does. They're the systems that get compromised. So a key thing I'll come back to again will be operational security. Don't just think about security architecture as a process that you do before it goes live. This is something that has to keep on happening. Would you agree?
And yes, and good. Something that I've seen a few times as well is outsourcing the development. So a company that has some business needs that might be security sensitive, maybe there's some privacy of health information or something like that, but they don't have the skills inside the company to develop it. So they'll outsource the development, get a dev team in, they'll build a system for them to their requirements, it'll get installed, and then the dev team leaves. And who looks after it? Who's the one that checks to make sure that new threats don't affect this application, that components aren't out of date, patching needs to be done, that sort of thing.
So, a quick apology. So for those people who actually saw the Prezzo yesterday afternoon. So for those who did, then quick 2-minute apology. But what I just want to do, I'm not going to do the big...
2-minute apology?
Yeah, I'm going to apologise for 2 minutes. So look, I'm really... No, an apology that I'll take 2 minutes of your time and recap something that was yesterday. So for those... While Kirk does a 2-minute apology for me.
I've got chocolate cake on my trousers.
Oh, man. You see, sometimes...
It's my special black trousers. They told me you're not allowed to wear jeans, so... Sorry.
Oh, no, that's fine. That's fine.
No, sorry. A quick 2-minute apology.
Yeah.
Continue.
For Kirk's chocolate trousers. So on the subject of chocolate trousers, and no, where were we?
Language Perfect.
That's right, Language Perfect. So Language Perfect. For those who for those who didn't see it yesterday, 2 minutes, right? I'm not going to apologise for 2 minutes. But for 2 minutes, Language Perfect.
2 minutes is up.
Oh crap! Now let's move on. Excellent. So, no. Okay, Language Perfect, right? So what it is, when I'm talking about operational security, so they are in fact, some of the people who were here yesterday could probably just tell me what Language Perfect do. They go, oh, you said. So they're a online schools learning website operated in New Zealand and Australia. Kids log into Language Perfect and they take just their Spanish and their French and stuff like that. Groovy. It's a very low hanging fruit, or a very, not low hanging fruit, a very low on the radar of why you would want to hack them. However, they ran their World Championship competition last year, this year, May 21st to the 31st. And just within hours of the competition going live, they came under an international massive denial of service. So a diverse, distributed denial of service attack. Took them out of operation. So what was interesting is that from Language Perfect's perspective, if they went back and threat modeled the application and why kids would want to, so you go, well, what would they want to do? They want to hack the results. They would want to go and be able to retake a test that they just failed. They'd want to be able to go and dupe and say that I'm the smart kid in the class instead of the one who can't do Spanish or whatever it might be. So they've got a whole threat model. Never in their design did they come up with what happens if we come under a massive international attack. So when it did happen, then of course everything broke and everything panicked. So this was an example of where to them operational security, they'd done all the great design up front, but they hadn't really considered what do you do when the fan is hit by chocolate off of Kirk's trousers. So
Great picture there.
I thought so.
Cool.
I thought so. Is it the fanning of your trousers or the chocolate?
So in the beginning, this is how software projects that I've been involved have worked. Management will come along with some business case and we want something built. It's going to be a web app, they'll say. And we need to get more customers. That's going to cause us to make more money. And we want to provide more services to the customers we've already got. That's going to make us even more money. And we want to do it cheaply, so you need to save some money. And sticky services, so to do with chocolate cake, you want to lock the customers in as long as you can. Hopefully they don't leave. So, make it usable or something like that so people don't leave our application. And, the other company's doing it as well, so we need to do ours faster so that we don't lose money. It's all about money. But in this sort of scenario, things that have unquantifiable costs or unlikely probabilities tend to get sidelined. Is that the right word?
I think it's a perfect word.
And basically the most you'll hear from them is if you ask them, so what are your security requirements, or is there anything we need to worry about? They'll say, oh yeah, make it 100% secure and make sure no hackers can ever hack it.
Absolutely.
And
we have sat down with the Mandian organisation. They go, oh, we need you guys to test the system, and here's our non-functional requirements, and exactly that: must not be hackable, must be secure. I'm like, well, okay, that's fine. It's going to take you about this long to do the security testing. Easy. So,
have you ever found an app that was unhackable?
Xero, of course.
I mean, apart from
Xero, that would be impossible to say.
No, I mean every application you're trading off risk versus something. So that trade-off. It's a trade-off.
It is.
Yeah.
Risk mitigation. So the cost of mitigating a risk versus the cost of living with it.
That's right.
From a business perspective.
So, and sometimes if you're really, really unlucky, the business requirements will say something like, we're in the health sector, so there's this ISO
It is
10029,
yes,
which is the health information something. Or you're dealing with the US, and there's supposed to be an extra A on HIPAA, I think. And you're dealing with US health protection issues, or you're dealing with credit card information. And these standards typically have rules about, how you transfer data from one environment to another, how you hash your passwords, cryptographic algorithms you are and aren't allowed to use.
Absolutely. Unlike because the PA DSS, because you've got PCI DSS for those people who handle and process credit cards, but the PA DSS is part of the same standards, but for the payment application. So this is if you are actually storing the credit cards at the back end and the PIN numbers and all those groovy sort of things.
So that's for things like DPS or banks, isn't it?
The banks,
yeah.
Yeah.
Cool. So I mean, that's pretty much all you get really, and it's our job as developers or architects to try and convince our business that security requires a bit more consideration.
So if we often then come back to, the secure development lifecycle, the software development lifecycle. So what we often start off with is, I know that many people, scrum down and have morning scrum meetings and those sorts of things these days. But if we just go back to the raw software development, says right at some point, management come up with a business case, you get your requirements, you design it, build it, goes live. Often the key security step.
That's a great Gantt chart.
Did you like that Gantt chart?
Yeah.
Yeah, it was obviously quite a quick project as well. I think they had like 4 days, or it was quite.
I think the Gantt chart probably took longer than
the project
coding
itself.
phase.
But I must admit that is actually what project managers exist for, though, isn't it? Basically, just to update things like Gantt charts.
Project managers here.
Are there any project managers here?
They're not going to put their hand up now.
So project managers spend a lot of valuable time making sure that we get this stuff right.
Yeah.
So do you have different colours on your Gantt charts? You see, she does. She's good. She's an expert project manager. Dual colour.
Oh, you can talk. You put red on yours.
Yeah, that's the point.
Okay.
So
Continue.
So what we often do, so the security steps that often happen are at the very end. So for instance, it's all good, it's been designed, it's been built, it's just about to go live. So at the very end of the testing phase, let's do the security testing now. Oh, and by the way, we should of course harden our servers and then patch them because they're the production servers. And I guess this is kind of like the security 101.
Yeah, and it's kind of getting a bit late by that time, really, because if you do find issues, it's really expensive to fix them. And typically, this end of the project, as you'll know, software development, even with the best intents of our project managers, tends to slip schedule, and things get compressed at the end. And it's not normally the developers that get compressed. We just take however long we want. It's normally the testing phase that they have to deal with it, which is unfortunate. But and security testing is one of those things. Like often security testers will come in, will find a list of issues. Some of them, like when Andy's company come in, they'll give you some high risk issues, some medium ones, and the customer will say, so which ones do you think we should fix? And we'll say, well, all of them. No, but if we only have 2 days till we go live, which ones should we fix? And that's a really awkward conversation to have.
I'd certainly, and I guess it's usually an awkward conversation with project managers, because often the PM will say exactly that. Well, can I go live with these things? And we're like, well, we've just told you the 16 critical vulnerabilities you've got on your public-facing website. Whether or not you go live is a business decision. So what we're looking at here. So again,
and normally the negotiation goes something like this. If I remember from when I worked at Aura, it was, so you've put 16 things as critical, but we don't think they're critical. Can you just send us a new report with them marked down to low so we can go live? And then Andy goes.
You said that.
And then Andy goes, well, you're paying us. I guess we can do whatever you want.
Absolutely. Absolutely.
Is that right?
Well, no. What we usually then do is we say, well, we can do that, but only if you want to pay for an extra 2 days to go and do some threat modelling. You see.
Yeah.
That's right. So it's always an upsell.
Yeah.
You know that. You've been on the receiving end.
Yeah, certainly been on the receiving end of an upsell. There was no double entendre there at all.
Seriously? I think there was.
So what was this slide talking about? Oh yeah, this is your slide.
So what we absolutely need to do here is look to wind forwards. What we'll be doing is that, so at some point, so we'll cover off, so when people talk about security architecture, we say, look, there's, we need to do the threat modeling and the security.
Have I got the wrong slide deck? You keep talking. I'll check.
Fine, look, that's this one. That's today.
That's today?
Yeah, that's good. Cool. We're here.
Cool, those slides were in the wrong order.
Jeez, that's fine, that's one, yeah.
Okay.
So the fact is that so we're going to do the threat modeling, the security architecture, you do the secure build, but they were in the wrong order. But one thing is that it missed time and time again is going back to the business for the risk assessment back at the business level and nailing those security requirements. And so one of the things that we often come back to is driving from the business case through the incident response planning through to what are the solid security requirements. And as we go through some of the examples, you'll see why we keep coming back to this. So just leave that in your head, that we need to, before we get into technical security architecture, then we absolutely need to nail how bad it is if this stuff goes wrong.
So we decided it was really important to have a transition at this point, but we couldn't decide what we'd call it. So there's some basic security principles that...
Stuff that you must do.
Yeah. There's some stuff to do. And we're just going to run through these principles. There's common things you've probably heard about. And just to kind of colour the discussion going forward. So one of the things... Lucky I wore my glasses. So you should always assume that the attackers have full knowledge of your system. They know how your application communicates, how the protocols work. They have all the source code. It's really embarrassing when people have your source code, by the way. Should assume that if something fails, you should design it so that it fails shut rather than open. What else? Should have least amount of privileges as possible. Make sure that you check things like authorization and authentication on every call to your service. Make sure that users actually understand and agree with your security principles so that they go along with it.
And I particularly like the psychological acceptability. So this is one of the things that a lot of the Zero developers failed completely on their psychological acceptability, but they were really bloody good coders. So hence why Kirk's still there.
Geez, thanks.
That's all right. No, that's fine. But I guess what you do need to bear in mind is that, so will people use highly secure systems? So we've got our kind of security properties that we look at, right?
Yeah, so this is an expansion of the old CIA principle, which is the lock people up in Guantanamo and throw away the key principle.
That's exactly right.
So confidentiality, integrity, availability, authentication, authorization, and non-repudiation. So the idea that confidentiality, only people can only see what they're allowed to see, that the data is not damaged or altered without the appropriate process going through, and that you can detect it when it has been done. That systems are up as much as they can be, and this is something that will sometimes trade off, because denial of service, like we talked about yesterday, is kind of hard. And also something that we trade off with, patch cycles and things like that. We just have to take the system down because security is more important. We have to make sure that we authenticate when we want to, that users are allowed to access what they access. And the repudiation one, which people find hard to say, that's about proving that someone performed an action. And so being able to go back to that person and saying that was you. And it's kind of linked to authentication. Like, you want to prove that the person that logged in and did something actually did it. So things like password policies and just not sharing passwords, administrator accounts that everyone knows the password to, that sort of thing.
Yeah, I don't think anyone does that anymore.
No, definitely nobody ever does that.
Shared user accounts. Yes, I'm sure you haven't worked anywhere that you left an organisation, went back a year later and just logged straight in as administrator again, did you?
That would be useless if you could do that.
It would be.
So that, and even my home computer I can never log into. The password changes so often. Yeah, anyway. So I want to do a run through of the threat modelling process. Now this talk isn't going to teach you threat modelling completely, and in fact that's kind of the engagement level that Andy does and that I did when I was working with him and I've done with them, we typically don't go down to the detail that Microsoft's threat modeling process goes down to, because often that takes too long.
Exactly.
But it's a good thing to know about and maybe work into your dev process and your architecture process. So I'd like to talk through it.
Yep.
So the threat modeling process that we're going to talk through came out of Microsoft's research. So over the last 10, 15 years, they've been doing a lot in secure development, and their latest operating systems are a lot more secure than, say, Windows XP was back in the day. And it's partly due to these processes they've put in place. So threat modeling is really a process for analysing your design and looking for weaknesses from a security point of view. So the first step is to diagram your system, and I'll show you some examples of the diagrams. And then from the diagram, identify the threats that will affect different components of the systems and communication between them. And then think about mitigations, so a full mitigation that completely stops the threat, a partial mitigation, or we've made a risk assessment and we're not going to bother with this type of mitigation. And then a validation step just to check if you've done enough. And this can continue on and on and on. And I guess the reason we're showing this is we'd like to encourage you to keep doing this throughout the life of your application, not just your dev cycle. So this is an example of a threat model. So this is from the Microsoft examples. So it's basically a data flow diagram with annotations. And this system allows users to use an admin console and update entries in the registry. And Microsoft have rules about whether users should be able to directly modify registry entries and stuff like that. So what they've done is separated into two components. So there's the host software component and the admin console component. There's some communication between them. And then the host software component talks up to some data stores, the registry and the file system. And what you do when you're diagramming your system is you kind of break it down into blocks. You break it down into external entities, so the actors, the people that are using the system, other systems that interact with your system. So at some point you're going to have to stop drawing your diagram or you'll run out of paper and just assume that that system is a box that's sending you data. Other companies, other places you get data from. Then the circles are processes. So I probably wouldn't go down to the COM object layer with my process diagrams, but that's because I'm lucky enough not to use COM objects. But what are the individual units of code? And this is kind of, you get into what layer of abstraction do you want to do this at. The data flows between the components and the entities. They use that weird notation for a data store with the lines above and below, which is basically anywhere that data sits at rest. And then this dashed line is used to designate trust boundaries. So where something of high trust is talking to something of lower trust. So in this example here, the admin console has a different level of trust than that host software did. So you've got that trust boundary there. So that's how threat model diagrams work. And there's actually a tool which snaps onto Visio, which is the Microsoft Threat
Modeling tool.
Modeling tool? That sounds too simple. I'm sure the name's more complicated than that.
It's got a far more funky name.
Threat analysis and modeling tool, something like that.
Who actually uses that? Who does threat modeling down to this level and uses that tool on a regular basis?
Cool. Okay, cool. I can spend the next hour on that. No, so we're going to keep going. But it's a cool little tool if you've got a Visio license, which I guess everyone here does. So once you've got your diagram built and you've got the picture, then you want to identify your threats. And so Microsoft have got this stride, taxonomy, that's the wrong word, categorization thing. Yeah. They've got this stride thing, which allows you to identify different sorts of threats. And this is really good for lay people because you can have some highly paid expert come in and just throw lots of ideas at you, but you'll probably find that they'll miss some things or one day the expert won't be there, and you need a more systematic approach. And Stride is quite a systematic approach. So it categorizes the threats that you might see into these 6 categories.
So who is familiar with Stride already? Some.
Cool, we're making strides.
Striding ahead.
Yeah.
So who here actually is a security architecture and does secure design?
Yes.
Cool. Who else here just is coming along to the architecture track and doesn't actually do any security stuff at all? Okay, so we've got a few
Everybody
people.
does security stuff
Okay,
in some
okay.
way or another.
Who is kind of like more of a dev and devs their own code and needs to make sure it's done securely?
Yes.
Okay.
Thank you for coming.
Cool,
That's
cool,
awesome.
cool. Excellent. That's right.
Cool.
So I was thinking if we kept getting no hands, it's like,
Who is here?
we've got a project manager, we've got an architect.
We've got enough people to do a government project now.
Yeah, pretty much. Well, no, all the rest, that's the steering committee, as everyone else that you see. Yeah. So they're the decision makers.
Cool.
Which is
I would just like to
never
point
going
out
to happen.
that your 2 minutes are up. Okay, so this is my slide. Stop stealing my slide.
blah,
So this stride framework. So we'll just go quickly through what you do. So you look at each component of your system and think, is spoofing a concern here? So spoofing is when you can impersonate someone or something else. So someone can pretend to be a different user. Someone might pretend to be a mobile phone. Someone might pretend to be Argentina. Something like that. And normally the thing you use to counter that is authentication. Tampering is when something can be modified, either when it's sitting in the database or on the file system, or perhaps as it's traveling over a wire. Or as it says, DLLs on disk or DVD, like anyone does that anymore. Oh, no, that's right. We don't ship them on a disk, but they still live on a hard drive. Yep, cool. They do. Repudiation, I've already kind of talked about that, so being able to claim that you didn't do it. Information disclosure, so that's about the confidentiality of the information, making sure that people can't see they're not supposed to see. Denial of service, we talked about that a lot yesterday, so being able to completely busticate a site so that no one can use it. And elevation of privilege. So those 6 categories of threats, really, what you can then do is look at your components in your system, and you can think about them in turn for each of these 6 categories of threats. And it's kind of a system for helping you think about it. So looking at, what's say, a data store. So this database, the things that apply to it. Well, tampering is potentially a problem. Like, what if the sysadmin, the database admin gets access to the database? Repudiation might be an issue, like how do we prove who updated a row in a database? Do we use triggers to store things or change tracking or whatever?
Yep, some of the login and auditing.
Information disclosure, what sort of information's in that database? How do we back it up? Where do we put it? Denial of service. Can people actually take down the database and stop the rest of the system from working? And you do that for other things as well, so external entities. So say a person, you might think about, what does S stand for again? Spoofing. You might think about whether a person's been spoofing or not. So whether, help me out here, Andy. So whether a person's pretending to be someone else.
Absolutely.
Cool. Had a mental block there, visual images. Repudiation is the person pretending to be someone else. So it's kind of a nice categorization there. The question mark there is sometimes repudiation works as it applies to data stores and other times it doesn't. So that's just why there's a question mark. It was going to be a half tick, but that was hard to draw.
You couldn't find it. Yeah, that's right.
No.
Yeah.
Cool. Okay, so basically you go through your diagram, you jot down the threats that apply to each part of your diagram. So if you're using the Microsoft tool, you basically kind of drill into the elements, give them numbers or however you want to categorize stuff, and then go through each threat and basically log what they might be. And this is just a text description of the previous diagram. At some point you have to stop, and so the Microsoft guys say basically once you get inside a process boundary, that's probably a good place to stop. You know, you can't take this all the way down to the method level unless you're a masochist. So don't do that. And then the other thing you do is look at those trust boundaries. So as I was saying, some components might be higher trust than others. So if your high trust code is taking data out of a low trust environment, it has to check that it's safe. So say you've got some user entered data and then you're taking that and putting it in the registry. So that copy from the low trust environment to the high trust environment needs to have a lot of validation around it, which wouldn't really need to happen in the other direction. In the other direction, what you're more worried about is that you don't disclose too much information. So depending on the direction of the flow and the levels of trust, you might also have different threats.
And I think so we see a lot of this in particularly web application security. So for instance, web apps, so you're putting in an attack on a web page, it could be just a SQL injection or something quite simple. But so the web app is taking it from an untrusted environment, but then when it dies or crashes or it fails to run, then it's giving you back an error message on the screen that describes exactly what happened. So that's when you're now divulging information from your app to an untrusted environment that says, I just broke here.
Yep. I agree. So then you go to the mitigation phase. So that's really about addressing threats. And like we were saying earlier, you win some, you lose some, right? Like as the security-focused person in your team, you want to address every threat because you know you'd rather spend an infinite amount of time on making your system totally secure. But really you've got 4 choices. And unfortunately, sometimes you have to accept the 4th. So the best in a lot of situations is to redesign the system. And this is something you can do at this phase that you can't do later on. And this is the bit that's frustrating when you're doing security testing is you go, this is just a busted design. This is never going to work. Do you have any examples of busted design?
Oh, we have some very, very, very busted design. I guess, so recently we had a large Kiwi company who had bought a system from overseas as an example. So the Koreans who had developed the system, it was a very large multi-million-dollar installation. And what they'd done is they'd come from a background of writing desktop applications that talk to their big back-end systems. So what they'd done is they had then gone and decided to build a nice Flash front end to make it a good, rich web environment. So what they'd done, they were used to building in the desktop application, it owned all the logic around what you're allowed to do. In fact, basically all business logic existed in the normal desktop application, and the back end was purely there just to stick stuff in and out of various data stores. So they rolled the same design into a rich web front end. So if you just think through the design principles here, we now have a rich web interface, and its theory is that if it doesn't show you an admin feature, you're not going to be able to click an admin feature. If it makes data read-only, then it just makes it read-only on the screen, and obviously you can't edit it. Now, behind the scenes, of course, was a perfectly web-accessible array of web services that did all of the normal CRUD activities you would expect, the create, retrieve, update, delete of just about every item in the system. And so as an example, the one successful kind of step it would do is some solid authentication. So you went into the website, it would authenticate you properly using some good techniques, so that was fine. Once you were in, you had an authentication token that would then be used on any web service you chose to call. So if you made a direct post to any of the web services at the back end, it would say, absolutely, I'm going to let you do it, because obviously the client let you click that thing and edit that thing and update that data. So what you ended up with a system that had solid authentication, so it had a big ring fence of all the different of all the users it could have, but it had 0 business rules and authorization.
That's with a Z, 0 with a Z.
0 with a Z, not zeros authorization. No, correct.
Cool.
So from a design perspective, obviously you come along and you have a look at a system like this and you say, well, okay, you've got about 200 exposed web services at the back end, so that's 200 vulnerabilities you have. Every single web service can be called as long as I've logged in, and they were just about to release a self-registration process, which then kind of made it slightly even more busted. And yet what was interesting, when it came back to the, so at design time, so we actually raised the first round of bugs, so the first 10 days worth of testing, like, wow, we're uploading files to the servers, we're editing any data that we like, this is really quite broken. And yet, unfortunately, the reply that came back from the Koreans was crikey. So you've told us now 63 things that are broken. And so they were going to go away and fix the 63 broken things. We're kind of like, architecturally, guys, there's a bit of a disjoint here. Architecturally, to have authorization in your client in a web land is broken. You need to repeat all of your business logic at the back end. So again, this is where, from a design layer, it was kind of broken.
I'm never going to ask you for an example again. This is my slide.
Oh, you said it.
Okay, so there's an example where if Andy had been involved in the design phases, and obviously he charges by the hour, as you can tell, then these problems could have been fixed for a lot cheaper. Cool. Okay, second point. I'm not going to... So apply standard mitigation. So there's a standard table of things that you can apply to each of these threats. I'll show you that in a sec. And the third choice, of course, is to invent something yourself. That's never a good idea. Chances of me inventing a cryptographic algorithm better than Bruce Schneier, very slim. Microsoft got it wrong, OpenSSL get it wrong, everybody gets it wrong. So it's normally a bad idea to invent something yourself. Or there's the fourth choice, which is to accept it, to say we think the risk is lower than the cost. And, so what if a few thousand people get their credit card number stolen, or whatever decision you have to make? Probably that's not a good one. So here's that table of standard mitigations. So to counter spoofing, you'll use authentication. I mean, this is pretty normal stuff that you know about. So which authentication method are you using? If it's web, it's probably cookie-based. To stop tampering, then you might use some Windows features or some signatures to sign the messages as they transfer from one environment to another, so that you know that the sender actually sent it. Similarly, for repudiation, you might also do the same techniques. You might have some logging where the logs are stored in a different environment. So they're collected off your one hosting environment, and the logs are stored separately, so that if the hosting environment's compromised, the log files aren't. Confidentiality, I mean, we see that all the time, just SSL encryption on your web pages. Access control lists to stop people seeing stuff they shouldn't be able to see. Denial of service, maybe you'll just put a quota like every user can only do 10 requests a year, or whatever your rule is. Could be business limiting that one. Elevation of privilege. So common things you might do there, validate your input to make sure people can't call database functions they're not allowed to. Make sure that they're in the right groups and do role checks. So that's a handy table to use. So what you're really seeing is this threat modeling process as kind of diagram, identify threats, decide on mitigations, rinse and repeat. There's a slide saying don't do it yourself. It's the mandatory, any security talk needs to tell you don't invent it yourself. So now we've done that. And I wanted to show the picture that I had here. And so then there's the validation step. So make sure that you validate and re-investigate your diagram. And this is the bit where it becomes ongoing. So as your application evolves, go back and revisit. Are there new components? Is there new data flows? Are there new threats? Have new threats come about? Like, for example, this month there's going to be a new threat against SSL release to Echo Party, which apparently is going to let you get people's cookies from another website. Interesting to see whether that turns out to be something or not, but keep that in mind and then go back and revisit whether your SSL implementation is good enough. So now you can talk.
Can I? Thank you. So I guess we've covered off, key sort of security design principles. What are the properties we want to look for? What are the principles we got? Stride. Let's look at all those bits now. But an area where we see it failing time and time again is when systems change over a period of time. So what we're going to do, we're going to start with a little example, right? So this is very much, what we call like the hello world of application architecture. So this is our simple, basic web architecture 101. We have a website. Behind it is a database.
Website, database. Oh, sorry, you probably know this, but that's a firewall. And that's a thundercloud.
That's a thundercloud, is exactly what it is. Yeah, exactly right. So here we go. So this is the basic design 101. And what we would do is if we followed a bit of threat modeling principles, we would say, well, okay, what happened? We've got a trust boundary here. We do not trust stuff on the internet, but we do trust everything on our side of the firewall. So a wee while ago, people realised this potentially wasn't a good plan, is that servers that face the internet sometimes don't last long if you don't look after them properly, okay? So if we follow like a bit of our stride design, and we can go, well, the first box that's going to get owned is, of course, the web server. So it's cool. So in our security architecture 101,
that's not really that cool, but yeah. So the things that might happen if the server gets owned, maybe they could elevate privileges to admin, jump onto other machines using that. Some secret information might get disclosed. They might screw with our data. That sort of thing. Absolutely so.
Absolutely so. So what we've done, many moons ago, then came the concept of therefore sticking another big firewall at the back end. And so this is where so we started life in DMZ land. It's like, okay, well, to mitigate the risk, we will block it from both sides. We now manage the trust boundaries between the boxes.
And so what we're really going to talk about is the life of an application as it's evolved. So pretend this is some kind of simple application that basically has a text box where people enter stuff, they log in, they enter stuff, and then it gets stored in the database.
Yep, no, perfect design.
Yeah.
Or maybe I enter my accounting data and it adds it up for me. Something as basic as that.
Yeah, that's right. That's our architecture. No, not that one, the previous one.
No, previous one?
Yeah.
So this is...
That's how simple it is, yeah.
Well, at least it was until they engaged us. So that was how simple it was until Xero engaged.
No, we had the same box.
Oh, yeah, good point. There was actually one box.
And also we had no customers. So.
Yeah, and there wasn't even a firewall. Yeah, it was just Kirk's laptop.
We weren't that bad.
Sitting at home on our ADSL. So if we then progress through, what we've now done, so we've done a little bit of stubbying, and so what we've done is just said, look, solution architecture-wise, nice and easy. What we've now got a couple of web servers, easy peasy. So we're coming through the front end, we got our web application, groovy. What we've then got is our business app at the back end, and we've got our web services interface between the two, and we now have a, what?
Bus app?
A bus app, we do. So we've got a bus management system. So we've got a web app and a business application layer. So that's fine. So this is where we have our secure architecture, and we go through and we do some stride on this, and everything looks beautiful. Now,
so you can see, obviously, we're not going to do the whole threat modeling thing on this. We're going to talk about it in more abstract terms, because there'd be too many little lines to draw.
And that's one of the issues, though, is that if you dive deep into your threat modeling, so in the flow that we had before, it's all about your processes and your data source. Sometimes you do need to take a step back. So again, if we come back to the simplistic view, because it's in web land, then we have HTTPS to protect all our data out on the internet, so it's beautiful.
So we've identified that information disclosure as an issue out onto the internet?
Yes.
Yep.
And then we've got simple HTTP at the back end, because it's now in our trusted boundary. So we're not expecting people to snoop data on the inside of our DMZ. So that's just HTTP communications. So we've still got a good design?
Yep, so you can enter text into a text box. The web server passes that to a web service. And the web service calls the database through the firewall. Yep.
Beautiful.
Cool.
Easy.
TDS. I think that's the only one port open on the firewall.
That's right.
1433.
Very tedious.
Yeah. I see what you did there.
Yeah. So what we're going to do, right? So we design our app. And then what happens is that, time passes.
It goes live.
It goes live.
We roll it to production. The team disbands.
And of course, when we rolled it into production, that was the point that we hardened down the production servers, made sure they were patched. We did some security testing just after it went live. Our project manager decided that it was all good to go because they were getting into trouble.
Welcome to Happy Place.
Oh, yeah. And then the
This
rest
is
of
what
the room
happens in the real world.
The rest of our steering committee in the government department went, ooh, we'll need to have a meeting about that next week and decide if we should stay live.
Someone needs to have a meeting about the rubber stamps we need to create to use in the meeting.
Ooh.
It's okay, I don't have to sell anything to
Yeah, no, you
government
don't. That's right.
departments.
Exactly right. Exactly.
your
Yeah, that's
issue.
why I didn't say that. It's just okay. Yeah. So we change over time. So what happened is that the management up on high have said, you know what, we now need a good mobile interface to this. That web's just so outdated. So we're going to have a new mobile application. It's going to run on all the main ones: iOS, the Android, BlackBerries.
Windows Phone 7.
That's the one. I knew there was. Yeah. Okay. Good point. Yeah. No, it's going to run.
We're going to be talking about
Windows.
some mobile considerations tomorrow, a little plug for our session. If you're going out tonight and partying, please remember that at 9 o'clock tomorrow morning, some people will be here
I know.
doing a session on mobile security. So,
Exactly.
yeah, think of us.
Think of us whilst you're still lying there hungover after TechFest. That's right. So at least, well, I guess, so what we could do though is that all those people who I guess know that they'll be too hungover in the morning, just leave us your little blue Watsits and we'll swipe you in at the door. And then we'll do your feedback for you afterwards. So.
Oh, yeah, you'll have to get hungover somewhere else. Yeah.
Okay, so what we have to do is, so we need kind of like a pickup mechanism, don't we?
I'm not going to go pick
We'll
up
do
anyone at
door-to-door.
TechFest.
We'll do door to door, right? Really?
No.
So,
Hey, hurry up.
So what we decided to do, so this new mobile app, what it's going to do is that we've chosen as a business, of course, we're going to reuse our existing infrastructure, of course. We're going to reuse our existing web services as an example. So what happens? So all of a sudden, we have our glorious little, so the little laptop there is coming in through our standard web interface that we've got existing. We've got these gorgeous new tablets now.
Yeah, they come with styluses.
Yeah, they do. Yeah, they do.
Visio's so modern.
I know. Jeez. So, but what they do is that they rip down, and so they now communicate directly with our web service server, which was the bottom one out of our two. So it's so cool. So we'd already built it, so it makes perfect sense that our mobile app is just going to call out web services.
Well, the problem with that design is that our web application is the one that's doing the authentication, and then it's calling to the web service over a trusted connection. So I assume the web service is probably not redoing that authentication. It's probably also doing the validation at the web server layer.
Good point.
What else is wrong with that? The web services are only listening on port 80 because that's all we were listening on for the web server to talk to us.
That is correct.
Anything else wrong with this picture? The cloud is black? No?
No, I think that's pretty much good.
Yeah, okay, cool.
So what do we get from that? So I guess what we do. So the story here is that every time we go and redevelop our application. So obviously now what we need to do is make some minor changes. So now of course we need to consider HTTPS all the way through to our web services now, because again it can't talk over HTTP, and yet we'll often actually find quite a few mobile apps being developed where people are quite happy in webland that we need to go over SSL for secure comms. But for whatever reason, we see a plethora of mobile apps where people just don't have the same consideration. So mobile apps are still passing all of their authentication data, all the data back and forth over HTTP to a bunch of web services behind the scenes. So it seems like a bit of a no-brainer, but of course it's still web traffic, even though you might think it's over just your GSM connection, but it still goes over wireless and.
Yeah, so this is one of those cases where introducing a new client device means we have to push a bunch of logic around in our application structure.
Absolutely.
We have to push that authorization into a different place, or perhaps stand up a new server in front of those web services or something.
Correct. So what we also do, and what's interesting is just something to note, is that these kind of crazy designs that we come out with at the moment are designs we have seen out in the wild with real customers. So these aren't just completely fictitious. This is what we see people doing. So
people actually have orange walls in their server rooms.
Yep. They really do. They really do, and green cables between them. So time goes on, and so the enterprise grows. And so as the enterprise grows over time, so now what we've got is we've added at the back end here a back end intranet or some kind of web portal that we use inside the organisation. We actually use the authentication data out of the AD. Perfect. And yet it still communicates to the same database that we use for our public web-facing stuff. Because, of course, we don't want to replicate the data anywhere. We'll just use the same sort of data stores. So this is...
So if you think about the threat modeling we did, where we're talking about trust boundaries, now we've got that data store in the middle that's connected to two trust environments. The low trust environment where the users are, and the higher trust environment where our intranet sits. And we probably can't go into it too much, but other web security talks we've done or other things you might have seen, like that untrusted data coming into the database could execute inside the intranet as JavaScript or otherwise, and potentially compromise other machines in the intranet.
So I guess that point you just made there. So so imagine now, so cross-site scripting. People are familiar with a cross-site scripting.
Yeah, that's okay. I thought we should go fast on that bit.
Yeah. No.
Okay.
No, cross-site scripting. So as an example, if this double clicker again. So if we did, as an example, putting in a cross-site scripting attack, going back to our little diagram up here. So I guess this is where we got the issue that we can deliver attack through the internet, but it actually triggers inside your organisation. So you see there was a short version.
Oh, okay.
Good.
I'll give you that.
See, I can do short versions.
I like what you did with that box as well. It looked really classy. Good job.
Box? You like that one there? What, with a little corner cut off?
Yeah.
Yeah.
Classy.
So it was I think it's the screen. It's supposed to be the same blue.
Yeah. Oh, yeah, that's
I know.
what it is.
But on the Mac, it looked great. What would you do, eh? Yeah. So next time we have Macs.
So that application gets released, that team disbands, and a new team comes along, and management says, we need our sales force to access this data entry application, type text into boxes and save it to databases while they're on the road using their mobile devices.
Absolutely.
So this is not the customers doing it, this is the sales staff doing it. And we want them to authenticate against the back-end authentication system. We don't want to have them in the WebAuth database. We want to go against the Active Directory. So we have one password store, we have one place where we can lock users and manage roles and that sort of thing. So how does that fit into our diagram?
So we actually end up with people with kind of this sort of more interesting design now and so there's not necessarily a third physical web server, maybe it's virtualized, maybe it's actually sitting on exactly the same box, but we've kind of introduced here a third web service layer that now are trusted applications that are sitting on our staff's bring their own devices machines are using.
I was expecting some points on there, sorry. Continue.
And so what that's doing is to look at the...
interrupts you all the time. It's so rude.
So you'll see from the little red lines running through that what we've now got is that one of the web service layer that's sitting out on our DMZ now has comms back to our Active Directory because that's where the auth is going to be happening. So if I'm using the app from my Windows 7 mobile, I want to be able to use my normal or login credentials inside the organisation just to get straight in. So, it seems like a perfectly good design that's kind of grown up over a period of time. This may not have been the design we would come up with on day one, but it's certainly a design we've ended up with now in kind of like year 3 of business operations. So this is often what we sort of look at as more of like our organic architecture. And so this is in fact, again, a perfect example of we have seen this in the wild with organisations with this kind of organic architecture where starts life as a web-facing system, then we start exposing some web services for application APIs, maybe mobile devices, then we turn into a bit of an extranet, and of course we want to be reusing our shared infrastructure and the stuff that we've built and paid for so far. But what starts to go wrong with this kind of system? Well, as an example, so we've had clients with maybe their web interface actually had some anti-brute forcing code on it. Maybe it actually ran some captures, so maybe it started to lock accounts out for a period of time if you started to brute force the website. However, that's not functionality they built into the web services. So the web service layer was just passing auth data in the XML headers. It was over HTTPS, but username password was actually included in the XML request that came through for the web services. But now what happens as well is that they're now starting to be used and web services are communicating with the AD, so it's actually using internal credentials now. So what you end up with is a system where you can brute force through a public web service made available for a mobile app and break into the user accounts of the actual internal AD users inside the organisation. Now that's probably not the sort of design that you'd be looking for.
So that was a real one.
A real example.
Cool. And other issues that we came up with along the way, so no, this is still talking about your example, isn't it?
Yeah, that's right.
That's okay, I'll talk about it. So in this real-world example, they also had issues where they were forgetting to validate at the business app layer, they were failing to authorize at the business app layer, and what else were they doing?
Well, so the other one that they actually had was in the shared infrastructure, coming back to all those little, all those little web servers that they're using in the same environment, because they're trying to reuse infrastructure, because they're not redesigning each time from a security perspective. They actually had both business but also life-critical applications. So the customer in question that these apps had to be up. In the case of an emergency, then they really were life-threatening applications if the data could not be made available. And yet they would be disrupted from an uptime if you attacked a side-by-side system alongside. So again, this is one of these areas where if you're looking at, say, denial of service attacks or escalation of privileges on one app, you need to be very aware of where over time it's grown up next to the other apps that sit alongside it.
So is that something like you've got a VM host that's hosting your web server plus some other stuff?
Yep,
and the
perfect
other
example.
stuff's mission critical, like call center app or something like that?
Correct.
Your web server gets hammered and the call center app falls over.
Correct. And in fact, you need to be careful of, I guess, any shared infrastructure all the way through. It could be your network layer, it could be the disk access, it could be a shared database, it could be a shared authentication system.
Yeah, I heard a story this morning, someone that had an evacuation of their data center and couldn't answer the phones anymore because it was the same building. They had to evacuate the whole building. So it's really hard to tell people that you've had to evacuate your data center. So that idea, I guess, of sharing resources.
Absolutely.
Cool.
So all of this is just really for all the basic stuff that we do. Then what happens is that we find people who suddenly start to come up with these more sort of exotic security requirements that they're having to now apply on the old systems that have been developed organically over a period of time. So for instance, maybe they're now adding classified data, or maybe, and when I say classified, I don't mean sort of government classified, but more of just sensitive information or legally privileged. Like as an example, a trading company where you're not allowed to get access to the new trading, to the stock prices until they're publicly released. And if you've got a database admin who can get hold of those prices before they should be released, then maybe they can do a bit of insider trading. So quick, Kirk, sell all your Xero stock now. Or buy now.
Xero as an example.
Sorry. Trade me. Sell your Trade me stock
Okay,
now.
yep. Selling my Trade Me stock.
You got some Trade me stock?
No.
Oh, okay. So what you also end up with, so for instance, requirements that like this will start to come along and change the nature of what you're designing. So perhaps it will now say you need some stringent logging and auditing of all users and admins, maybe even starting to build in application aware of security attacks actually built in, alerting of suspect behavior. Also, I guess when we talk about forensically sound, so what we're talking about here is can we actually start to modify the data and that repudiation again? Can you see that the data has been modified? So again, what ring fences do you have to put on your coders and your admins inside the application?
Yeah, that was something quite interesting when I was talking to someone that did that forensic work for making court cases against people that hack into systems, is that basically anything you do to the computer in question can mean that you can't take the person to court.
Yep,
Like
correct.
they have a forensic way of imaging a machine and then somehow they sign it or something. So
Yeah,
that
so you actually
prove
take a
not to be
hash
tampered.
of the whole drive before you start.
Yeah.
So when we talk about like hashing passwords and stuff, so if you're actually going to do like some forensic work, you literally have to take a copy of a drive at the raw layer, and you actually hash the data that's on it before you even start. So that then if you change one bit somewhere on that hard drive and you get a different hash, well, that shows that the data has been tampered in some way. And if you don't, quite right, then you can actually be kind of kicked out of court because you can't prove.
So you might be able to find out who did the thing because
That's
you've
right.
been going through, trawling through logs, deleting files, getting the system up and running, but then you can't do anything about it.
Correct.
In court, at least.
So I guess, so we now touch again on what we talked about, that operational security. So if we're now talking about the stuff that we're going to be designing a little more hardcore into the system, so you really need to be aware of, so who is it who is going to be watching your system on a regular basis? And so again, you've got to consider that the ops team are not necessarily application or even security experts, and yet these are the people that are often watching it. So as an example, we have several times before now run a security test over a system, over a website, and it may be that we're actually requested to do it without telling the operations team or the dev team when it's happening. So over the next quarter, security test the system and see how it survives. Now what is interesting is that sometimes we'll actually find the reason that the company realises we've done a test is because the marketing team got really excited about how popular the site was suddenly getting. So this is your marketing team and now your security operations team because they're the only ones looking at the web logs. It's like, seriously? You also have that idea of knowledge leakage. So as Kirk said before, so your experts who develop the system perhaps aren't with your organisation anymore. So who is actually watching it? And we find this, so when we come into an organisation, we find that the dev team are the one looking after a system. That is an absolute sort of alert bell straight away because you're like, right, it's just gone live. Your developers are the one monitoring the system and making sure it's not being hacked. Well, how long is that going to last? Right until the next project manager says, your stuff's late, your stuff's late. Well, no, you probably don't say it like that. Your stuff is late. Please hurry up and write your code faster. So
My Gantt chart's gone red.
exactly, you're in the red. Cook's always in the red.
Yep.
Yeah.
Thanks.
So
Okay, new rules. Don't mention 0 and don't mention red. Okay,
oh, okay.
cool.
Oh man, what's left? Yeah. So we've also got, so there's the concept of, well, of have you been hacked? So when we come down to operational security, again, we will often run a security review, we'll find security holes, and then we'll find evidence that the client has already been hacked in some way. And we'll kind of go, well, you've got 16 critical security flaws, and it looks as though they're being exploited already. So again, how would you know if you have been hacked, and who's actually watching? So again, so many times, if you go back through the logs, you can see the system's been compromised. It's just no one's looking. And again, this is what we come down to, operational security.
And you can end up with a lot of data flowing through these systems. So think about how big your log files get from the code that you write, or and interspersed in there somewhere are security events. There's systems like Splunk where they're basically designed for processing large amounts of data and spitting out alerts and that sort of thing. Do you see people using systems like that?
Oh yeah, definitely so. Well, like if you were looking at
examples,
in the example that I was using,
we use Splunk.
Splunk.
Yeah.
So we use Splunk from the logs like from F5 WAFs, stuff like that. So where, as an example, we're talking about the denial of service attack on Language Perfect yesterday. So at the network layer, over 4 days, there were 200 billion network attacks that happened in a 4-day period. So that's the kind of stuff where you want to make sure you've got some good logs just to go through them
I
quite
think that
carefully.
might have exceeded our Splunk license. if we had
Yeah,
that
I think
happen
it
to
did,
us.
eh? 'Cause, yeah.
If we had that happen to us. But yeah, you pay per event, I think. Anyway, I'm not a spunk salesman. Continue.
Continue, thank you very much. And you also need to be, I guess, very aware of new and emerging threats. So who updates you old apps? As the text says there. Is that your spelling again? So we can't talk about Xero, Red Hat,
No, you
or
can talk about my spelling.
mistakes.
So whose job is it to actually keep in their head which components are inside each application and which ones need to be updated? Is it the ops team job to know that this application is using, version 3 of Microsoft Drawing.dll or some other made-up component? Are they the one that's supposed to read the advisories? Is it the dev team's job when they do another project to realise they need to go back and address issues in old projects when they find something new? And I think probably most of us in this room have the issue where once a project is finished and it's gone live, you don't want to touch that thing because it'll probably fall over. Everyone except for Bevan. But everyone else, they're scared that their software is going to fall over if they look at it, right? So, so how do you solve that problem? And patching.
Patching. Well, actually, coming back to, again, new and emerging threats and patching. So one of the things you are going to take away from this is make sure if you're not doing your own dev and you're actually using third-party components or you're getting anyone else to write your software, make sure there is a clause in the contract about keeping your software patched against new and emerging threats. So one of the things we see time and time again is that we'll come into a system that was written about a year ago, now it's full of security holes against all the new stuff, and you go back to the original software developers or the vendors and say, oh my God, it's full of security holes, and they all turn into change requests, and it's going to cost you a bloody fortune to fix security flaws, because it was never in the contract that it needs to be updated against new and emerging threats. So the Korean example was a perfect one. They said, nah, we developed this as per your original instructions. It meets requirements perfectly. You never said how unhackable it should be. So that's where they should have had must not be hackable. That would have bloody solved it.
But you're never going to get someone to work for free, so...
But if you build it into the contract, then you would expect your vendor to say, okay, I will charge you a certain serverless level agreement to be able to update my code against new and emerging threats. So you'd expect to pay for it, but you need to have it there.
And what often happens as well is that you'll get assigned some junior guy at that company and they'll be the one that has to fix the issues and they'll spend the first week figuring out how the system works. That's always really frustrating. Anyway,
so
we have 46 seconds left.
Here we do. And 46 seconds worth of, so if you fell asleep somewhere in the middle, right, this is the bit that you actually need to take away. So, actually, yeah, is he? Oh, no, see, he's still there, look.
He just woke up.
He's just chilling back, yeah, there's early. So what you need to look at, so what you need to do, reevaluate the security of your architecture and your applications every time you add a new component to the system. So don't assume because we designed it once, because it's running, we'll just add a new bit on and life will be good. Always go back and reevaluate the security requirements. Always go back and reevaluate every time you change your business requirements slightly. And as security architects, of which I think we had 2 in the room, so both of you guys need to make sure you work closely with the business. So the business owns the risks, but you do need to understand the things that break stuff.
I think most architects wear that security hat. We're going to keep talking.
That's not bad.
Most architects will wear that security hat, even if they're not labelled as a security architect. But yeah, you need to understand the whole technology stack, which is kind of overwhelming, really. And that main point, which we've laboured over and over, is to design and plan your systems to be attacked. So think about the logging, the alerting, who will notice.
And one of the things we said yesterday, so run fire drills, and by fire drill, so actually run through what you're going to do in the event of an attack, whether it's who's going to restore your data, who's going to turn the system off. It's always a great one in incident response land. So who is going to turn off your systems if they're actually under attack right now? So is that one of you guys as the devs? Do you go, looks like the system's being hacked, we'll just go poof and turn it off to protect the data?
Bag's not making that decision.
Yeah. 0. Poof.
Ooh, 100,000 customers. So we might take a couple of questions. I just wanted to plug tomorrow's talk. So tomorrow we're talking, as I said, on mobile security. We'll be talking about sort of a more nitty-gritty dev-focused talk on the internals of mobile apps. If anyone here knows how to project a Windows Phone physical device on a projector, I'd really love to know because I can't figure out how to do it. I'm going to have to use a webcam or an emulator. Cool. Okay. Anyway, we can talk about that later. That's probably not an important thing for right now. Are there any questions from the floor? Yes, over there. So the question was, when you've got application with multiple tiers like that, is it safe to assume that there's a safe network between them and you can just do plain text comms? I think lots of people do that. It's a bit of a trade-off, really, isn't it, for speed versus security?
Yep.
So yes, you'd have to threat model. Do we have to stop?
Well, I guess
If we
we've got
don't
a bunch
stop
of people
now,
just
no one will
going.
clap for us. Yeah,
Yeah, so
let's
it's
stop
like-
now.
so I
Come up
guess-
and ask questions afterwards.
We're
Yeah.
right there. Come and ask some questions afterwards. And yeah, thank you very much.
Cool. See you tomorrow.
Cool.